Here's your sealed enclosure. No fans, no airflow, and a component sitting at 200 degrees Fahrenheit. The question is simple but critical. How much heat is that surface actually shedding through radiation alone? That's exactly what this calculator answers. It uses the Stefan-Boltzmann Law to compute radiative heat loss from any surface. You plug in four things: your surface area in square inches, the surface temperature, the ambient temperature, and the emissivity of your material. It handles all the unit conversions behind the scenes and gives you results in both watts and BTU per hour. Now here's why the formula matters. Radiative heat transfer follows a fourth power relationship with temperature. That means small increases in surface temperature create dramatically larger heat output. The formula multiplies the Stefan-Boltzmann constant by your emissivity, your surface area, and the difference between the surface temperature raised to the fourth power and the ambient temperature raised to the fourth power. Sounds complicated, but the calculator does all of that instantly. The other variable that changes everything is emissivity. A black anodized aluminum surface has an emissivity around 0.95. It radiates heat extremely well. Polished aluminum sits at roughly 0.05. Same material, same temperature, but nearly 20 times less radiative output just because of the surface finish. That's a massive design lever most people overlook. So where does this actually matter? First, sealed electronics enclosures where convection is limited or non-existent. Second, spacecraft and satellite thermal design where radiation is literally the only way to reject heat. And third, industrial applications like furnace wall losses or high-temperature equipment where you need to quantify radiant energy to size insulation or cooling systems properly. If you're designing anything that runs hot in a tight space, this calculator gives you real numbers instead of guesswork. Find the link in the description below to use this calculator and read the full engineering guide.